All right. Welcome, everyone. Welcome to the construction site. You cannot see, but we are almost in a construction site here. And yeah, it's my pleasure to welcome everyone to I think, the third edition of DevTools Porto. And today we're excited to have Pedro Costa from Avenue to speak about, I guess, why they are using Elixir. And so give it up to Pedro. Thank you.
Thank you, everyone. Okay, so just a disclaimer, half of that is because of us, so we're moving next door. So if anything goes wrong, forget that I said that, because I don't want you guys chasing me. Okay, first of all, hi. As we said, my name is Pedro. I'm the lead engineer at Avenue. And I'm here to talk to you guys about Elixir. And especially, I want to give you guys an overview of the language. And I want to explain and showcase a bit about why we decided to go with Elixir for Avenue, especially because it's still such a niche to hire developers working on Elixir. Okay, so the shameless plug, this is the place I work for. I asked for the logo because we just rebranded. Nobody sent me the logo, so there's the domain. Okay, and now to the actual content of the talk. First thing is, in order for us to understand Elixir, we first have to understand a bit of Erlang and why Erlang came to exist and what it brings to the table. So first thing we need to be aware is Elixir runs on the Erlang virtual machine. And Erlang itself was developed by Ericsson in the 1980s. It started in the 1980s. Most of the adoption came in the early 90s. And it was built to operate telecom systems. It's essentially, think about the primordials of internet, where everything was done as phone calls. Even a simple internet access, you had those really nice 56K modems with that really cute sound connecting. And all of that was just calls. And at the time, they were trying to develop this system that could get through millions of calls in different places, sometimes in hundreds in single switches. And the system had to be reliable, had to be fast, and had to be scalable. And from that system, Ericsson at the time evaluated a bunch of existing languages, and they ruled out most of them in favor of Prolog, Parlog, sorry about that, and Lisp. And then they went around trying to go deeper into those languages to develop the system. And they actually realized that while those languages fit what they were trying to build, they were not, the execution model for concurrency wasn't there. So they decided, they got to the conclusion that they needed to build something from the ground up, inspired in those languages, but something custom. And that's how Erlang was born. And with Erlang, I swear I'm not doing anything. With Erlang also came the OTP, the Open Telecom Platform. And that platform, think about it this way. OTP is for Erlang, as an usual standard library is for a language. It's not just, it's a bit more than a standard library, but it's a set of libraries and middlewares that they had to integrate into the language to make it feasible to operate communication systems throughout the time. And it stayed that way as a very niche system for many time because, what? Apparently broadcast stopped. Did something happen with the broadcast? Yeah, I'm gonna try it again. Says I'm connecting. I don't know. Is it the mic? Oh, this is wonderful. Apparently my iPad thinks it's connected, so it's decided to start updating things. I swear the iPad was connected the whole afternoon, so I don't know. Let me try this again. Can I do this? It's trying to start the broadcast. Otherwise, I'll just keep trying, but I can keep going. So the idea with this is they had to build this entire language and a whole infrastructure with it. The whole OTP package that comes with it allows you to actually leverage most of the perks of using the language. And what are those perks? Erlang, the whole ecosystem around Erlang and the Erlang virtual machine grants a couple goodies, like fault tolerance. There's a saying in Erlang that goes, just keep calm and let it crash. The idea in Erlang is that you don't have to plan for all the error cases or every reason the system will crash. You just embrace the fact that it will crash and you allow it to restart. So the idea is that with Erlang, most things are organized in processes, and those processes are organized in a tree. And if some process fails and crashes, there is a supervisor that's in charge of just acknowledging that the child process failed and just starting it again. So you just assume that you're going to fail and you reset. And this is one of the strengths. The other one is the actor model in Erlang makes it a very concurrent language. So in Erlang, you have the notion of a process, but it's very different from the typical operating system process. It's a very lightweight process. You usually can spin hundreds of thousands of processes for your own application in a single machine without too much hardware, because those are literally very small processes with a very lightweight footprint, specifically designed so that you can spin multiple things and to run at the same time and just let the machine handle it however it can. The virtual machine will be very good handling those things. And let me see if I can get the broadcast to start again. Otherwise, I don't know how we're going to proceed with this. Okay. Yeah, maybe that's always an option. It's not showing on the live stream, but yeah, apparently. It's showing on the live stream and the sound also. Okay. So nice. The slides save just for my own notes and for the people around here. Okay. Continuing. So the idea is that you have a very highly concurrent ecosystem. It's also distributed. So Erlang is the Erlang virtual machine is built in a way that if you have multiple machines working, as long as they're network connected, you can just start them with the same secret, for instance, and they'll actually be connected right away. So you can execute code from one machine to the other, and if you actually spin them all with the same code, you can make them coordinate and pass messages as if the process was actually in the same machine. For this reason, it also has a very low latency. And okay, just to link with the slides that are now visible, highly current refers to the actor model that I explained before, and the fault tolerance. Okay, so now you're gonna. Some of you would pose the question: okay, so if Erlang is so great and the Erlang virtual machine is so great, why didn't we go with Erlang itself? This is actually a quote from José Valim, the creator of the Elixir language. And it explains that if you look at Erlang in the 21st century, remember this language was designed in the 1980s. While it is a very good language, it still misses a lot of things that a modern or a younger developer will come to expect. Even a more seasoned developer has been working, for instance, with Python, with Ruby, would come to expect certain things from the ecosystem that you might not have in the Erlang. So, José Valim, because of this, decided to create Elixir. So we go to the Elixir language, and this is actually a very cool thing about the language is every time you try to explain how Elixir relates to Erlang, you have to first explain the ecosystem because it fully uses the ecosystem. You can call Erlang code from Elixir transparently, but the Elixir itself has a Ruby-like syntax, has Lisp-like macros, which actually give it some sort of metaprogramming superpowers. It goes beyond the macros. So it's a very flexible language, even to build domain-specific languages like Ruby, for instance, was and still is. It's has a very rich standard library, very inspired in Ruby, which was inspired in Python. Just a detail that's important here. José Valim was actually one of the core contributors for Rails, the biggest framework in Ruby. So that's why got so much of his inspiration from Ruby. It also has closure-like protocols, which most people don't know what that refers about, but it's a way of extending elements of the language in a functional language, which isn't very easy. Like, it has a very cool explanation in some talks, but just go look it up if you're interested. But trust me, it has closure-like protocols, if you know what that means. And one very cool feature of the language that Erlang doesn't have, it's at the same time a compiled and interpreted language. So the idea is that everything that you run on Elixir first is compiled and goes into Beam bytecode and runs on the virtual machine, Erlang virtual machine in Beam code. But while compiling, your code is actually executing. So it's running the expressions that you have in there, which give you a different level of pre-computing things at compile time. It also has a lot more stuff. This is just, if I stopped looking at Elixir around 2016, I think this would be a pretty comprehensive set, but since then it has been gaining more powers every day. Just not worth it referring everything here. Okay, this leaves us with what? A functional language that has a very rich pattern matching system thanks to Erlang. One thing that José Valim actually added on top of this that Erlang doesn't have is the notion of pipelines, which gives you a very rich syntax to express data transformations, which is if someone for everyone here who has been working with functional languages, it's one of the best perks of functional language is when you treat everything as a data transformation. Very hard to convey some of those things in object-oriented languages. And not only is it able to use OTP to its full extent, it actually builds on top of OTP and extends it. It brings some new toys to the party that I actually don't know if you could call them from Erlang. Maybe. It comes to reason that you maybe could, but I don't know. It's for free in Elixir. Okay, so this is the time I would like to showcase a bit of the code, but I think that for that, I'll have to ask someone to come and pick up the mic because I need 2 hands. Let's give him a round of applause, please. Thank you, my lovely assistant. Okay, let me share my screen here. And let's go to the terminal. Okay, this is just, as you can see here on top, I'm just, wait, it's not there? Oh, is there any way we can, maybe? Yeah, I have to swap it here. Let's see. Do we have a time limit?
No.
Yeah,
I mean,
nice.
we need to go to
The beers are getting cold,
Yeah.
so
getting warm. Yeah, but
getting warm, yes.
they're getting cold.
On the contrary, yes.
Okay, so now I feel the pressure. If it's for beers, sure. How the mirror is, how the mirror
terminal is not showing us on the screen.
It's gonna be there in a second. It changes.
There you go.
There you go. Okay, so as you can see here on top, the only thing I've done was called IEX, Interactive Elixir. It's just, for anyone familiar with Ruby, for instance, is the same as calling, what, Bri? Or IRB. So it's just an interactive console for you to deal with Elixir. Now, Elixir, very simple language. You have what you would come to expect as an assignment, but it's actually a matching. So if you try to write something like this, it fails because it doesn't match one side with the other. Now, the matching allows you to do some cool things, like this is a literal array or list, if you want to be picky about it. So you could just do something like A, B, C, and connect with 1, 2, 3, and it just matches all the elements of the list. More they can do with this, you have the notion of a map built in. So literal maps would be something like this. You have some cool sugar syntax on top of this, which would be like a structure. If I defined it, well, let's define it. So in order for you to store your code, you can, of course, declare functions, but you can organize your functions in modules. So let's define a module, greeting, and let's just say that this is a structure, and let's say that it has a field name, and done. What did I go? Yeah, sorry. Thank you. Keep forgetting that. There we go. Thank you. And now you can just declare your greeting like this, and say, for instance, this. The advantage of using a struct is if you try to use a field that's not declared in the struct, you get an error. So it gives you some assurance over that. So, but you can also look at the greetings and, for instance, ask map from struct, and you can see that this is just a plain map. It has it's nothing more than a special key to say which module this struct came from. And then the whole runtime will make these checks to ensure that the key exists. So more than this, we can define functions to, let's say, sum to numbers, and we can use that block syntax, or we can do it in line, x plus y. Did I do something? Yeah, inside the module. I forgot I'm not inside the module. Let's do greeting again because I want it. And now I can do greeting dot sum 1 and 2. There we go. And there's a 3 in there. Trust me, it's right in the border, but it's there. We can also declare functions inline and anonymously. So fx y, and we just say we want it to be x and plus y, and now we do fx plus 1 and 2. Yeah, this is actually one of my pet peeves. I hate the fact that you have to put a dot to call an anonymous function, which usually you don't need to, because you use this to pass the functions as an argument to another function, and you just let the function inside handle this detail. What can you also do? You can also do the exact same function, but using a shorter syntax, where you actually use the ampersand. Where is it? Hello. Ampersand, and just say I want the first argument and the second argument, and there we go. And you do the exact same thing, calling G, and there we go. So this is a very quick overview of the language itself. So as you can see, aside from this little work with the dot, it's a very understandable language. It is very much inspired by Ruby, so it's reasonably easy to read, and it gives you a lot better code to maintain than Erlang, in my humble opinion. So I think we can stop the share here. Sorry, thank you, my lovely assistant. I'll round an applause for him, please. He did such an amazing job. Okay, let me just swap back here. Okay, I'm trying not to be very boring, because this is obviously is not a tutorial on the language itself. I just want to show you an overview, because for me, one of the details of learning a new language is very much how that specific syntax will sit with the way I think and the way I like to program. For instance, I'm gonna be the first to admit I've done it, but I don't like Go. And I also don't like JavaScript, but I don't have any alternative because I'm a web programmer. Sorry. Okay, that comes with being a full stack. So why did we go with Elixir specifically. The reason is mostly because of I/O. And for this, I have to explain a bit of what Avenue actually is. In Avenue, we're building a communication platform that's aimed to basically be the tool for DAOs to collaborate on. DAOs are distributed anonymous organizations. It's a concept that came with, I think, first mentioned in the Ethereum paper, so it's somewhat related with blockchain. The most correct term would be Web3. So think about communities that are distributed throughout the whole world that are trying to collaborate to achieve something. And they have a very specific set of problems that don't exist when you can gather everyone and sit them around in a room. They have to be able to collaborate despite the language that everyone speaks. So essentially, it has to privilege written communication to let everyone go around and translate the previous messages. It has to be very friendly for asynchronous communication, because you might have someone replying at what would be 5 a.m. for another person. And you have to give them the tools to basically suppress out the noise. Because if you go into a DAO, has anyone here ever participated or even opened the Discord server? Usually they work on Discord for a DAO or a community with more than 1,000 members. Yeah, 2 people. What happens in the general channel? It's mayhem. Nobody can get any point across. And essentially, if you want to build a DAO, a distributed organization, most of the times there are some values around transparency, openness, giving everyone the right to weigh in. But when you want to open the discussion to everyone, basically nothing comes out, because it's the ratio to noise and entropy in valuable information just becomes, the noise becomes so high, you basically can't take out anything. So we're trying to build tools that allow these teams to collaborate. We're researching with them what are exactly their problems, how we can help them focus and discuss around issues, and everything comes down to communication. This can be chat, this can be posts, this can be something in between, like a forum discussion or some other paradigm that we come to develop that we don't still have. This might be voice messaging, calls, something like that. So we are sitting ourselves in a niche that's around communication. The problem is communication. So if there's one thing that we know we'll have to take care of, it's a lot of transactions. We have a lot of information coming in and we have to answer them all. So I/O is our problem. It's not a CPU bound problem. We don't have a lot of math to crunch. We don't have new blocks to mine for a blockchain. We don't have memory concerns. We're okay with just buying bigger machines. What we need to take care of is a massive amount of people trying to communicate at the same time and try to extract value from that. And that's what Elixir and Erlang are very good with. If you have a problem that involves heavy crunching of numbers, if you need raw performance, this is not the toolchain you need. You need something a little more bare metal, something I would say like Rust. If you have a very big problem and you have trouble just managing the sheer amount of memory that you're going to use, I don't know, whatever people in big data are using, I have no idea what the language there would be, but it's definitely not this. But if you have an I/O problem, which is the typical thing with communication, with web development, to some degree with IoT, this is the platform that is giving the best results. And the thing is, this ecosystem has been battle tested for the last 30 years. The first instances of Erlang were deployed for mass usage in the early 90s, I think 91, 92. So this gives us at least 30 years of these systems being there on the run in production and being evolved. And unlike what happened, for instance, with Java, which had Sun Microsystems doing a very good job marketing it and it being taught in universities and whatever, Erlang was a very niche ecosystem being built for a very niche purpose by a very niche team, just focused on dealing with communication. And I think that answers, it's the best answer I can give on why we chose to go with Elixir. It's not the perfect language, it has its quirks, and the dot is just my pet peeve, it has a lot more. Like everything, it will keep evolving, and it's still a bit of a pain to hire developers for, because you have to train most of them. It's easier to convert someone from, for instance, Ruby or Python, as long as they have some background in functional programming. At least I've tried it to understand the concepts. But still, for the problem that we have at hands, is by far the most promising tool for the solution we need to develop. That's it. Thank you. I'll take any questions, by the way, if there are any.
Is there any questions?
Yeah, please.
It may sound sorry. It may sound not a perfect question, but I will try to ask. So now you are making research and you found that Elixir is perfect for I/O. But how you can prove this? Yeah, like you make a performance testing, or when you are trying to make this final decision. Okay, I will go with Elixir. How you make your research, you found it's perfect for the telecom, but what will be the second or the following steps to prove it?
Okay, so it's a very good question, but the hack actually I need to answer it in multiple steps. So first thing I want to be clear about is I've learned about Elixir in 2015, so I've been following up the evolution of the language. And while I tried it and worked with it in some client projects, I mostly been working with Ruby until like 1 year ago. Now, there's many things I could point out on why I prefer Elixir to Ruby, and like 80% of them would come with the fact that it's a functional language and has pattern matching. And for me, it hurts nowadays to even think how I would name a function in Ruby, just because it's the same function as the one above, but it receives different things. That's a problem you don't have with Elixir, because you can just use pattern match and it's a different function. So on the expressiveness is already a language I like a lot. So first, let's put it out there that I already had some bias towards Elixir. Now, the thing is, if you already have a solution and it's working and you're having performance problems, probably you have a lot better things to try before switching the language and the runtime. So I come from the high performance computing background. I specialized in it, although I haven't been playing with it for almost 10 years now. But the thing is, almost always, if you start profiling your application, you'll be able to find a bottleneck that has nothing to do with the language that you're using. That said, there are some languages and runtimes that will hinder your ability to evolve in the machine. So for instance, until a few years ago, Ruby was one process machine. Doing anything multi-threaded on Ruby, or even having multiple processes, was a bit daunting. It had the global locking mechanism. In order for you to extract the full power of your multi-core machine with Ruby, you had to actually go the extra mile. You had to probably bind yourself to C or something like that in order for you to be able to extract the parallel power. While with Erlang, since everything is expressed as very lightweight processes, the virtual machine just translated to the multi-core paradigm very easily. Even more, if you start thinking about clusters, for instance, my experience, if you go with Ruby, you would actually do one instance of the server, spin multiple instances, and then have like either a queuing system or a distributed storage system like Redis to have them communicate in some way. But connect the machines directly one to the other, you wouldn't do that, at least my experience. With Erlang, that comes for free. So Elixir can take full advantage of that. You can spin the same application in 1,000 machines or 1,000 virtual machines, and they will, as long as they are connected in network and they're set up to use the same secret, they will all connect as a single cluster, and you'll be able to just throw processes back and forth between one and the other. So this gives you the ability to fully leverage the scalability of even if you don't go to heterogeneous platforms, just a multi-core system you'll be able to take full advantage of the system, of the hardware. Now answering your question. After we decided that our problem is I/O and Erlang fits the system better, if we already had the solution, I would of course first profile the existing solution and see, is my existing solution actually failing on I/O? Because there are many things that can go wrong at other levels and can be hindering your I/O because you have some pipeline just spending a lot of time processing, and you just go and optimize that, and suddenly you don't have an I/O problem. So I wouldn't change the language as an existing solution, but if you start the solution from scratch and you know for a fact that you're just gonna have I/O issues when scaling up, Elixir is definitely my #1 option right now. Does that answer your question completely?
Yes, that's true. The question, because as that's the tricky part. How you do finally? Okay, you know that it's good for I/O, but finally you need to make sure of everything, and this is time consuming for sure. If you started to go to try to check everything, so yeah, I was trying to understand in your case how you proceeded with following steps to go and continue your path.
I can also extend on this. Given my background and my familiarity, I would either prototype in Ruby or Elixir, because those are my favorite languages. I would go with Ruby if I had something that needed to be built very quickly and that I knew the ecosystem had a lot of tools. Because one thing that Elixir doesn't have right now, it's a lot better than it was 5 years ago, of course, and it's going to improve, but one thing it doesn't have is the same level of ecosystem that you'll find in Python, in Ruby, in JavaScript. So there are lots of things that you're going to need, and you're probably going to have to get your hands dirty on some open source project to get things out the door. There are lots of things that we're trying to use, and we're finding that the last version of those libraries were published 3 years ago. So we need to go there and fork it and see, actually, are there any security problems with this, or can we just start using it and fix whatever problems we have next? So there's that extra care, and I'm not gonna lie, sometimes the bill is high. However, we know for a fact that Ruby, Python, they would require us to invest a lot more time setting up infrastructure and in the infrastructure itself to get to the stage we are right now. To give you a clear example, last week we had our biggest DAO so far joining the system. We're still in a beta stage and just letting people come in and in drips. But we had the biggest DAO coming in that we had. Just that DAO alone brought more users than all the others combined. Of course, our system was put to the test, and it failed the test. There are 3 points in our system that failed, that crashed violently. In that point, not because we were using Elixir, that's the funny part. Elixir was actually behaving very well, but on the front end, we made some shortcuts, and we are putting extra stress on the server. As the moment we fixed those points, like deferring the searches, using pagination as we set it up, yada yada yada, just worked. And we went from full. Oh, the free Zoom meeting ended. Okay. So you didn't even getting the stream out the door?
The computer screen?
No, the cameras.
No, yeah, everything is okay.
Just the screen was.
Oh, okay. So that. Okay, but that is still streaming. Okay.
Perfect, yes.
Thank you.
Careful, yes.
Okay, so still not out of the woods. Where was I?
You fixed the problem.
Oh yeah. So the thing is, once we fixed that issue, we went from almost getting to 100% of memory usage, which was what was breaking the server, to suddenly being 20%. And we're actually running the lowest machine available on Elixir right now. So it's so far our system is being able to handle, now I think it's in the hundreds of thousands of users, not every day, full day, because we're still in beta, but it's being able to handle hundreds of thousands of users with a very small machine. Our costs with infrastructure right now are very low. No?
So maybe just a quick question.
Sure.
So if I remember correctly, Erlang was message passing.
Yeah.
So you have to learn how to do this as opposed to other people that are used to doing like locks and shared memory. So do you find it easy to actually do message passing, and or you don't even need to do that in the applications that you are building?
Okay. I actually have to answer that in 2 steps, because the fact is, for me, message passing is trivial because of my master's degree and the fact that I specialized in HPC and I had to build applications working in clusters. So for me, it's already natural to just use message passing for stuff. For someone who doesn't have that, I reckon in some cases it might be tricky to understand what's happening, especially if when you have to separate the processes, because you have, even inside the same machine, it's exactly the same as if the process is 20 machines over. You have to call the process by its name, you have to name it, or have to have its reference in some way, and you have to send a message to that process, and then the other process has to handle that message. That all comes from OTP. So you have to learn a bit about how that works, but in terms of using it, it's very easy. It comes out of the box. It's just there, and there are plenty of tutorials, and the documentation is very rich around it. That's one thing that Elixir and Erlang are very good at. While with Ruby, for years, we were almost scared or ashamed of writing documentation because your code has to be self-explanatory. It doesn't happen with Elixir. It doesn't go to the point where Java was at some stage where you have like set X and this sets X. But the documentation is actually very rich. It gives you examples. The examples themselves can be turned into tests, and for that reason be kept up to date. And the message passing, it's the translation that the abstraction that Elixir built for some of the OTP things are fully documented with all the examples that you might need. So I would say that the concept comes almost for free. You just have to waste a bit of time reading.
Okay. Is there a good place to get started with Elixir, like that you recommend? Like one single. Don't give me like a Google search. Like I can say.
No. But I'm gonna be straightforward with you. The Elixir Lang site is the best place to get started. Aside from that, just go and look for Elixir casts. It's the equivalent to Rails casts or Ruby casts or whatever that was back in the day. They are very rich with tutorials. There are lots of stuff there. I didn't have any need whatsoever to go on YouTube and just look for random tutorials anywhere in my Elixir life. Just those and the official documentation, they'll work like a charm.
Okay. Any other questions? Or otherwise we can go have a beer and thank Pedro again. So let's thank Pedro again.
Thank you, everyone.
Thank you for coming, and yeah, please give us some feedback if you know anyone or if yourselves want to give a talk. I'm just gonna go to this side so you can see me. Yeah, my lovely assistant. Okay, I like that one.
I'm gonna turn this one off now.
And yeah, so give us some feedback about what you want to hear next for the next edition. A little announcement: next edition we'll do DevTools with DevOps. So we'll combine both events, and it will be end of November. I think 23rd of November. And yeah, actually, I'll be giving a talk about pull requests and this new technique that we call fluid pull requests, on what we're actually doing. So yeah, if you can come and give us some feedback as well on that. And yeah, thank you so much for this moment. Let's enjoy some beers.